Welcome back, guys, to day 20 of the Cyber Advent 2024. We're getting close to the end, guys. We got 4 more days after this one. It's shaping up. Day 19 was like super crazy. We did some game hacking. We learned how all that stuff works. But yeah, we're going to get into it. We're going back to more of a blue team today. So we're doing some log analysis of a pcap file in Wireshark. So that's what the focus of today is. Learning objectives are going to be how to investigate network traffic using Wireshark, identifying indicators of compromise in a captured network packet, and then understanding how control and command servers communicate with compromised systems, or C2 for short. So we've got an interesting day today. This is going to be super important for you guys that are wanting to do become a SOC analyst or security engineers or even network administrators, as a lot of this is stuff that you're going to be doing. So if you haven't already, go ahead and start up your machine for the day. I will catch us up on the story. So McSkitty sat at her desk staring at the pcap file Glitch had just sent over. It was from Marta Mayware's computer, the latest victim of Mare Malware's log running schemes. She smiled, glancing at Byte. Looks like we'd have to use Wireshark again, eh, boy? Glitch's voice crackled over the comms. Need any help analyzing it? McSkitty smiled. Thanks, Glitch, but I've got this. So boom, there you have it, analyzing some pcaps. So here we're going to be introduced to some terms. Here they're talking about how C2 servers actually work. So whenever a machine is compromised, the command and control center or server C2 drops its secret payload into the target machine, and then the secret agent is meant to obey the instructions of the C2 server. So you can think of this like a persistent reverse shell, right? So once the payload and the computer are compromised, it is establishing a connection to this control center, and it's checking every so often. It's specified by the attacker how often it will check, 4 new instructions what to do. And this is common for things that people that create botnets. So what they'll do is they'll have all these computers connected to a C2, and then when they're wanting to attack or do something with the compute resources they have, they'll send instructions via the C2 server to all the agents, all the compromised systems, so that everything's executed at pretty much the same time. That's how C2s work. And for this room, we're using Wireshark. So what Wireshark is, it's a network analysis tool. And what it does is monitor all the traffic that is going over network. So if you wanted to actually boot this up on your network, you could see literally every device communicating and doing what it does over the network. However, most of this traffic will be encrypted because that's just the default these days and people are secure. But sometimes you'll be able to see unencrypted traffic, which will allow you to see what's happening in plain text. But you can see here, Wireshark can analyze traffic and display information in an easy to navigate format, regardless of the protocols used. So HTTP, TCP, DNS, etc. It can reconstruct back and forth conversations in a network, and we'll take a look at that today as well. And then it allows easy filtering to narrow down essential details, very helpful when doing analysis. And then you can also export and analyze objects that are transferred over the network. So pretty much you could get a stream and then export that stream into like a file and use this in your investigation or incident response, whatever you're doing in the blue team scenario. And they do link to some rooms, so if you wanted to get a better understanding, better grasp on how Wireshark works, which I highly recommend as a blue teamer, then you can go to these 3 rooms, do the challenges there. But for right now, we're just focusing on today. Now what we're going to do is we're actually going to dive into the traffic analyzation part of this room. So we'll go ahead and go over to our machine. We'll double click this and boom shakalaka. So what we'll do is copy this over and hit enter. All this is doing is we're filtering down the traffic to only be from this source IP address, which is the one that we're analyzing today. And you can see here all the packets show up. So that's good. So now we've narrowed down our analysis a tiny bit. There's still a bunch of packets there, but we're narrowing it down as much as we can. So we're going to see some interesting packets highlighted with an arrow as shown below. So it looks like an HTTP stream that we can follow. So let's go ahead and find that on our end. So scrolling, here we go. All right, so we found it, and what you can actually do is do right click, follow here, HTTP stream. And what this is going to do is going to put this in a nice little window for us to see what happens step by step, so it's easier to analyze essentially. So boom, we can see this first one was a post HTTP request, and it just says I am the mayor. Next, we did get slash command, and we ran who am I. So we ran who am I. We ran the exfiltrate command on this file, credentials.txt, and then we also see the key that was used to encrypt, and that was successful. And then we see the encrypted file is here. So we'll go back over here. So we can see initial command exfiltrate. So this is sure to be something. So here they're going to explain what's happening. They're just showing us a different view, but it's always better to just do what we did, to follow HTTP stream, which they actually do right here. Boom, and then they can see what we were seeing. So here they explain what's happening. So if you follow the HTTP stream for the get command, you'll see the request to the same IP destination. Interestingly, the reply that came back was a command commonly used in Windows and Linux systems to display the current user's information. This communication suggests that the destination is attempting to gather information about the compromised system. So usually the reply from the C2 server contains the command instructing the malicious program to do what to do next. So yep, and then if exfiltrate, safe to assume we're just taking data from the system and transferring it over to the C2. So this is an example of what it would look like when a compromised system sends over to C2. So it'll say something like, it'll check if the connection's still good, and then the C2 server will say, we'll kind of respond to that and be like, yeah, we're good, no instructions right now, or yeah, we're good, here's your updated instructions. And that way they're always connected, and they call it beaconing because that's what they call it when something reaches out to connect to something. So in this instance, the payload, the compromised computer is beaconing, reaching out to the C2 server, asking for new instructions or a new directive to see what it has to do. And then the C2 will decide, or the person running the C2 will decide whether or not to give it instructions or if anything new is happening. So in this scenario, as we saw, if we come back over here, go to stream 3, we can see that whatever's being sent, like this file right here, whatever data is being sent to the C2 from the compromised system, Marto Mayware's computer in this case, is being encrypted using AES ECB. And they actually include the key here, which is very unsafe for them, that they use to encrypt, right? So how encryption works, right? It is not the same as hashing or encoding. These are all three different things. And we'll break out the whiteboard here. So it's pretty simple, right? Encryption is creating an obfuscated code or string using a key, right? And there's two types. There's symmetrical and there's asymmetrical. Asymmetrical is the safest option. Symmetrical is sort of kind of safe, but if your key is compromised, you're donezo. So how symmetrical works is there's one key. And how asymmetrical works is there's two keys. There's a private key and there's a public key. And so how this works, right? Symmetric is one key for everything, right? So you're going to use that one key to encrypt and then later decrypt whatever you're doing. So that's how symmetric works. Asymmetric's a little different, right? So if you're sending something to someone, you're going to encrypt using your private key, and they can use your public key to decrypt. And then if someone is sending something to you, they will use your public key to encrypt, and you have to use your private key to decrypt whatever they send you. And this is the security, right? Because one key is known, one key should never be shared, because then your whole system is compromised. Next, we have encoding. So encoding, fairly straightforward. You've seen it before. These are things like base 64, hex, URL. So there's a bunch of different encodings. All encoding does is take one string of text and obfuscate it into something else. And we can do this by going to CyberChef. Probably be a better way to show you guys. And then before we do that, I'll go over hashing. So hashing is how passwords are kept secret. And all hashing is a mathematical function which spits out a basically string of characters based on the input that you gave it, right? So if you, and we'll go to CyberChef to show you this. So we'll do SHA. Well, okay, so we'll do SHA. Yeah, they do. So 256 is the most common one. So password, right? What we're doing here is we're taking this word and it is now this string. Okay? That is how hashing works. We are just basically creating this string, putting it through a bunch of math, and then we get this long string. And then now that's how we can store it. And the way we check this is you cannot, like, once you hash something, you cannot like take it back, right? How hashing works and how verification works with hashing is a little bit complex. We don't really need to get that deep into it, but all it does is it hashes whatever input you're putting and compares it to the hash that it has on file, right? So for example, our password is password, right? This is the hash associated with this word based on this algorithm. So now when I go to log in and I type my password in and I hit log in, the system will automatically hash this, whatever input we put for password, check if that hash is equal to the one it has stored on the server that you put when you created your account. If it matches, it will log you in. And that's how hashing works. All right, so next up, encoding, right? So we'll do base 64. That's like the most common one. So boom, you can see here, all it does is change this to this, and that's encoding, right? And if we took this and we did from, then, and we put the base 64 encoded version, then boom, we can do that. So encoding is reversible, right? And so is encryption. Hashing is the only one that's not reversible. So there you go. There's your crash course on hashes, encoding, and encryption for the day. Let's get back to the actual programming. So where were we? Right. So they're sending this key. They're using this encryption method here to encrypt the file. So basically what we're going to be doing is seeing if we can decrypt this. So we'll just copy this. We'll go over to CyberChef. And then we're going to do AES in here, decrypt, and we have to, so this is the key, right? Or we don't, so this is what we want to decrypt. And then we need the key. Okay, so this is just what we did. So ECB, and the reason why I'm choosing ECB is because it says ECB right here. We'll go back over here, hit the copy, put that in there. Unable to decrypt. So yeah, that'll do it right there. So I actually missed this last digit 9. So and we get this right here. Oh well, that kind of spoiled it, but yeah, if we come here, it's gonna do its best to guess like what this actually output is. In this case, it says hex, right? So what we would do is come over here and do from hex, and then boom, we get the flag. Copy that over, and that's the answer. So there you have it, guys. What we'll do is we go ahead and go through the answers, make sure you guys have those all good. So what was the first message in the payload of the C2? So we come back to the stream, we can come here, put 1 in the stream, and we can see mayor. I am the mayor is the first message. So that would be the answer to that. What was the IP address of the C2 server? So we could see it in here. It would be this right here, because the computer would talk to the C2, right? That's what we're doing here. That's why this IP is for the C2. It's because we're reaching out to this IP to saying, you know, slash initial, right? And then it's responding with perfect. Okay. Next one. What was the command sent by the C2 server? We'll just go to the next stream, to the slash command one, and this was the command, who am I? And then what was the name of the file that was exfiltrated? So if we go to stream 3, it will tell us right here, file name was credentials.txt. And then the last one is, what is the secret message sent back to the C2? And we did that by AES decrypting. And just so you guys know like how I did this, right? Just in case it's not clear. So here is where they tell us the encryption type and the mode. AES ECB is your chance, and they even tell you, is your chance to decrypt an encrypted beacon with the key, to specify the key they're using, this. So that's how I got the inputs for the key here and the mode, and then everything else is fine, right? And then the thing we're actually decrypting is in stream 4, which is here. So this is what we want to decrypt. So we take that, paste it in here. It gives us this output. And then if you aren't sure what this is off the back of your head, you can go to this magic wand and it will try to help you out. And in this case it did. It said from hex. So then we added our from hex into here, and boom, it decrypted into THM secret 101. So that's how we would get that flag. And that is the day. So if you want to learn more about Wireshark, they got another room here. To recap, we analyzed the traffic, HTTP traffic of a compromised computer beaconing out to a C2 server. And the entire conversation was over HTTP, so we could view it in plain text. What we discovered is that the beacon was checking the connection. It was established. The server responded with yes, we're connected. Then the server executed the command to the compromised system to exfiltrate data from the computer and send it over via encryption with AES. And then what we did was they did provide the key in the encryption message over HTTP, so we were able to see what key they used to encrypt. And using this information, we decrypted the information that was sent over, and we got the final flag for the day. So overall, pretty cool day. Important blue team concepts here, analyzing a network traffic file using Wireshark. Yeah, if you guys enjoyed the videos, leave a like. If you want to follow along, hit the subscribe button and share this with one friend that you think would benefit from this. This is Cyber Sensei Aaron. Peace.